Hello everyone, in this video I'll be solving the problem huge grid easy version. So it was asked in CodeChef contest starter 201. So let's read out the problem. So given a binary sequence A of length n, we construct an n cross n matrix B as follows, wherein if I is less than or equals to j, then B of ij will be summation of A of k from k, A of k, k is from I to j, okay. Otherwise, B of ij is equals to B of ji. Got it? So, define a path from 1 1 to nn as a sequence of pairs I1, j1, I2, j2 up till I 2n minus 1, j 2n minus 1. So, guys, I'll tell you this is a greedy problem. So, this is very easy. After this video, you will come to know like it is very easy problem. So, yeah, so don't skip this video. So they have given where I1 J1 is 1 1 and I 2n minus 1 and J 2n minus 1 is nn, and Ik plus 1 J plus 1 is basically I of k plus 1 comma j comma k, or I of k comma j of k plus 1 is I mean either of these two, and k is from 1 to 2n minus 1. The path sum is defined as summation of b of I comma j, wherein this I comma j belongs to p, this path. So whatever path you will be following and value whatever is there, so that is the path sum. So your task is to find the minimum possible path sum. They are going to test cases, and for each test case they have n as integer length of the string a, okay. So in the next one we have string a. So it is easy, let's try to understand. So they have given three test cases. In the first test case we have 0 1 1. So in the first case we have n is 3 and string as 0 1 1. So what they are saying is, let me not call this string a, they have given in the question is capital A, so let me take small a only. So this is a string 0 1 1. So now what they are saying is, out of this string you will have to construct string b, whose b matrix will construct, whose size will be n cross n. What is n? N is length of the string. And if you want to construct this, there are two conditions. Now if I is less than j, what is I? I is basically the row, j is column. So in this case n is 3, so let me take I is, this is I, downwards, this is I, it is having 0 1 and 2 because n is 3 here, so I am taking, and here we have j, and this is string b, I mean matrix b. We have 0th column, first column, second column, right? If I is less than j, which means when you're taking, let's say this cell, in that case your I value is 0, j value is 1, so 0 is less than 1, that is true. So when you're considering these things, so your this value b of ij, your b of ij is given by summation of a of k, where k I have taken a small, so I am taking small only, a of k where k starts from I till j, meaning when this value you are calculating, the value at this position, so that will be given by 0 comma 1, right? So you have I is equal to 0 and j is equals to 1, which means your k is running from I to j, right? So your k is running from I to j, which means it will take the value of 0 to 1, which means you have 0 comma 1, and 0 to 1 value is this one. This is 0th index, this is first index, this is second index in the string. 0th index, first index, second index. So 0 to 1, what you have value? 0 plus 1, which is 1. So your value at this position will be 1. So that is the thing they are saying. And one more thing they said is that if I equal to also is there. If I is less than equals to j, then this is the condition. If I is greater than j, so now your value, this b of I, your b of ij will be like b of j comma I, right? Okay, so if you try to see this condition, this is like a basically symmetric matrix, you can say transpose of a matrix. if you consider this B is equals to B transpose in this case. What is transpose? I'll tell you. Let's say you have a matrix 1, 2, 2, right? You have 1, 1 here. You have 2, 2. You have 3, 3, let's say. So this is one of the matrix, and if you want to transpose, so whatever row elements is there, that will come in column. This is the first row, it will come in first column. So you have 1, 2, 2. Whatever row element is there, this is in the second row, it will come in second column. So 2, 1, 3. This is in third row, it will come in third column. 2, 3, 1. If you try to see now, this is matrix B, let's say, and this is matrix transpose matrix. Here it is looking. So if you try to see, each and every elements are same, right? So each and every element is which means this is a symmetric matrix. So according to question, if you see, since this is a symmetric matrix and you are okay, let's first construct the matrix from this and then we'll try to come to the second part of the question. So so it's easy now. You have to find this value. Okay, so I is 0 here, j is also 0. I is 0, j is also 0, right? So when I is 0, j is 0, so it is coming as first condition. So you'll have to take the value from I to j, which is from 0 to 0, which is 0 only. So this value will be 0, right? Okay, why it is 0? Because my a of k, basically index from 0 to 0, only one index will be taking and its value is 0. Now let's take j is 1. I'm considering for this one, as I've already told you, but let me tell one more time. So now this value will be you take 0 index and 1 index, 0 and 1. So what is the value here right now? 0 plus 1 is 1, so that is true. Now let's calculate for this value. So you will have to take from 0 to 2, like 0 comma 1 comma 2, all index value you are taking. So if you try to sum up, 0 plus 1 is 1, 1 plus 1 is 2. So here value is 2. And now I'll not calculate this value because, okay, even if I try to calculate, let me calculate now. Basically, while doing these things, I'll be calculating only the values diagonal and upper left matrix. I'll not be counting the downward, because in the question there's if I is greater than 1. So in this case, I is 1, j is 0, right? So if I is greater than 1, so your b of 1 comma 0, this value is equivalent to b of 0 comma 1, which is here 0 comma 1. So this value is this one. So even if you calculate only these values, this matrix, I mean upper triangle matrix, so the other values you can calculate easily. So if you want to calculate the value of 2 comma 0, it is 0 comma 2. So 2 value will be coming here. Now let's try to calculate here the value of this. So wherein I is 1, j is 1. I is 1, j is 1. When I is 1, j is 1, which means you are taking from I to j, and it is from 1 to 1, which means only one index will be taking from the a. So at one index you have the value 1, so you are taking only 1, right? And let's take this. I is 1, j is 2. So you will be taking 1 comma 2 index. So 1 comma 2 summation index is 2. So here you have 2. Now once you have 2 here, which means at 1 comma 2 you have this. So at 2 comma 1 will also be same because of this condition. You have 2. Let's try to find this value. So this value is like from 2 to 2, right? I is 2, j is 2. So you will be taking only index 2. So at 2 you have 1. So this is the 1. So once you find this matrix, but I'll not be doing in the problem, so let me explain just to understand how I came up with the solution. So once you find this matrix, now your task is to find the optimal path. Okay, so in order to find the optimal path, you will be taking 2n minus 1 steps. What is 2n minus 1 steps? Now let's say you are coming at this position, you will move forward. Okay, you will move downward. 2 steps happen, like 1 step, 2 step, 3rd step, 4th step, 5th step. So when your n is 3, so it is 2n is 6 minus 1, 5 steps. So you're taking 5 steps to move here. Only 5 cells will be reaching. So your task is to reduce the uh, path sum. So in order to reduce the path sum, you will be taking the shortest path, right? So now let's understand one trivial case wherein you will understand how to whatever path I've just now have drawn, this is one of the optimal path. So how do I say this is optimal path? Let's try to take one example wherein your a is 1 1 1 1. Okay, 4 times you have 1. Now if you try to find a matrix, so this is a 4 cross 4 matrix. You have index 0 1 2 3 0 1 2 3. These are j's and these are i's. So as I said, you will be calculating only the values of this matrix, upper triangle matrix. So in order to find that matrix, when I and j both are 0, when I and j both are same, so you will be taking only one value, right? You will be taking only one value because I and j are same, one index you are taking, so you will be inserting one. When you are taking this value, you will be taking from 0 to 1, right? When you are taking 0 to 1, so you will be taking 0th and 1th. So this is 2, 0 1 2 3. For clarity, I am taking index. When you are taking value of this one, you will be taking the value of 0 1 and 2, which means it is 3. It is basically the prefix sum. So right, it is prefix sum. Now when you are taking this value, it is 4. It will be from 0 to 3, 1 2 3 4, right? Now again, since this is a symmetric matrix, you can put these values here. Now you want to find the matrix value of this one. When I is same, j is same, which means only one value will be taking. Again, it is 1. When you're taking next value, it will be from 1 to 2, which means 2 value taking. So in the prefix sum, since this is a binary, you have either 0, only 0 1. So whatever value you will be getting at the right hand side, all will be greater than the current cell value, greater than or equal to, because if it has 0, let's say 1 0 0 0, so you will be having all these same values. But yeah, you will be having same values, but you have let's say in this case 1 1 1 1, so you will be having greater values. If you want to calculate this value, so this is like I is 1, j is 3. So index 1 2 3 you will be taking 1 2 3, its value is 3, right? So that is the reason the right hand side value always be greater than the current value, greater than or equals to. So if you want to calculate this value, it will be 1, this is 2, and this is 1 again. So from this, since you all be taking n minus 1 steps, so and exactly you will have to take n minus 1 steps only, because diagonal is not possible. If there were less than n minus 1 steps, then you could have taken the diagonal, and diagonal would be the optimal path, because in the diagonal what you're doing, you're taking only one elements value. So diagonal elements will always be either 0 or 1. In this case, if you see string has 1 1 1 1, diagonal element is 1 1 1 1. In this case, if you see diagonal is, string is 0 1 1, your diagonal is 1 1. So that is the reason they have asked us to take 2n steps. If you take diagonal elements, you will be taking only 4 steps, 1 2 3 4. But in order to take 2n steps, you will be taking these steps also. So you will be moving forward, downward, forward, downward, forward, downward. So when you take these steps, how many elements you are taking? Basically, see, 4 are there and here 3 are there. 4 plus 3 is 7, and which is 2n minus 1, right? So, and as I said, you will be not taking these steps. You can take 2n minus step in this way also, 1 2 3 4 5 6 7, but this will give you a maximum sum path. You want to minimize it, and as derived in the question, so if you want to find the right hand side values, that will be greater than or equals to current values. So that is the reason we are trying to move only one step right hand side and one step downward. So if you do this thing, so diagonal has the exact string values. So even if you move to the right hand side one time, so since it is binary 0 or 1, so its value will always be um, greater than equals to the current one, but its value will not exceed, difference will not exceed with 2, right? Difference will not exceed 1, not 2, 1, because when you're taking two elements, let's say let's say it is 0 here, so this value will be 1 only, right? Because you're taking sum from 0 to 1, it is like 0 to 1, which is 1, but since I've taken trivial case as 1, so its value is 2, so always like shortest value will be there, so you will be moving to this path, this path. So yeah, that is it. I think now we can solve easily. Like we will not be constructing this whole matrix, as we know we need to travel only these values, right? So now how do we do that? So in order to do that, we will take I as 0, j as 0, because in the question they've said you will have to start with 0 0 and you will have to reach till n minus 1 n minus 1, at the end cell you have to reach. So as you see, first time when you are here, so its value, whatever value is there, right? So you will be taking only one time, right? 0 to 0 means only one time you will be taking. So in the whenever I and j are same, you will be taking only one time its value, I mean either j or I, because both are same, so its index is in a, so you will be taking one time. So I'll run a loop. I'm writing pseudocode. Your I should be less than n and j should be less than n. So when you come into the loop, you will check if I is equals to j. If that is the case, and you will take one answer as this is basically path sum, which will be initially 0. So when I and j are same, you will basically add into answer the a of I value, and this is, since this is a string, this will be char, you will subtract it with 0 character, so you will get some value. So this is the thing. If I and j are not same, if they are not same, what you were doing, you were taking adjacent elements, right? Like I'm taking only this path, which means the difference, if you see, if you are taking this path, I is 0, j is 1, so continuous two elements you'll be taking. If you see this one, again I and j are same, you will be taking only one time. If you see these elements, so you have I is 1, j is 2, so difference is only 1. So basically when I and j are not same, you will be taking summation of these two values, right? So your answer will be a of I minus 0, this is one value, plus the second value j will be taking, so that will be a of j minus 0. And now the question comes, how do you travel in this path? So if you happen to see, we are at 0 comma 0, so initially you will be moving j to right hand side, so your I is same, j you are moving. Next time what you are doing, j is same, I you are moving. So basically one time you are moving j, I, j, I. So initially what will be, we'll be moving j. So when you are moving j, I'll take one boolean variable, increase I, and it will be set to false. So I'll check if that increase I is present, which means I'll have to increase I. So I plus plus I'll do, is it looking, yes, else I'll do j plus plus, right? And at the, after this else, what we'll have to do is we'll have to reverse the value of a boolean value of increase I. So reverse, you can write here, increase I is equal to not of increase I. Why? Because one time you'll have to increase j and other time you'll have to increase I. So if you do this thing, you will get the minimum possible path sum, and this is the most optimal solution. I think you guys got to know how to solve this. So let's try to code it up. I'll be coding here. They've given test cases and they've given n. So test case is handled here. I'll take n, and they have given a string a. I'll take a. I think you guys got to know how to solve this. Um okay, so now I'll take answer, which is basically the path sum. Initially it will be 0. As I said, I'll take two variables I comma j, which will be initialized to 0 comma 0, because that is the cell wherein you will start and you will have to reach n minus 1 j minus 1. Now as I said, I'll take one boolean variable increase I. It is set to false initially because first time from 0 comma 0 side you will be moving right hand side. And one more thing I just forgot to say, whatever method I showed, this is the diagonal optimal path. But since this is a symmetric matrix, you could have taken this way also. This, right? Basically, the diagonal elements whatever you have, and the next right hand side, upward side or downward side, you can take elements. So this will give you the maximum path sum. So I'm doing this way. You can try this way also. Both will give you the same answer. So yeah. Okay, so when I'm moving right hand side, first time that I'll be moving right hand side, which means j I'll be increasing. That's why increase I put it as false. I'll be running a loop till I is less than n and j is less than n, and I'll have to check if this I is equals to j, which means our answer will be increased by only one time a of I value, because we have to take only one index, so it will be a of I minus 0. Else you'll have to take both the index value, which is a of I minus 0 plus a of j minus 0. I think you can optimize here, like if I is equal to j you have written, and else, like every time you are adding a of I, right? So you can write if I is not equal to j, so like this you can put out of the loop, and you can write if I is not equal to j, you can put a of j plus plus. You can do that, but let me put in a code readable format. So I've added the path sum. Now I'll have to increase I and j based on this increase I variable. If increase of I, which means I have to increase I, else I'll have to increase j. Once I increase them, I'll flip this value of increase I, which means if it is true I'll put it false, if it is false I'll put it true. So when I'm coming out of the loop, I have my shortest path, so I'll have to display the answer. Let's try to run it. Yeah, it got passed. Let's try to submit in the CodeChef editor. Let's try to run. We should be getting 501 and we're getting, let's try to submit it. Yeah, it got accepted, and I think this is one of the most optimal solution. Basically, if you try to consider the time and space complexity, this loop is learning only for 2n minus 1 times, and no extra space is used here, so I think this is most optimal. And if you if you understood this problem, you could like this video and subscribe to my channel and share to the ones who is in it. So thank you guys for watching the video.